So at a high school basketball game, the gym can fit 400 people, and X of those people are adults, and Y of those people are students. So when I write an equation for this, my units have to match. So I'm matching people with people with people. And so this equation would be X plus Y equals 400. Because again, I know 400 is my total. I don't know how many are adults, I don't know how many are students, but I know that if I add those two groups of people together, their total would be 400. The next thing I know is that adult tickets cost $5 each, while student tickets cost $2.50 each, and I'm trying to achieve a total amount of money of $1,375. So to do this, I would write my money equation, 5x plus 2.5y equals $13.75, because it's $5 per adult, $2.50 per student, for a total of $13.75. Now to graph, because both of these equations are in standard form, where x and y are on the same side and there's a number, I'm going to use x and y intercepts rather than slope-intercept form, because if I wanted to use slope-intercept form, I'd have to isolate y first. And so intercepts is actually going to be more efficient. So to graph my money equation using x and y intercepts, I would do 5x plus 2.5y equals 1375. Now I learned that when I'm finding an x-intercept, I know that the y-coordinate is 0. So that means that I'm trying to find this missing number when y is 0. And so if I were to replace y with 0, I would get 5x plus anything times 0 is 0, so I'd be adding 0, so I don't even really need to show it, and then equals 1375. If you feel more comfortable actually putting 5x plus 2.5 times 0 equals 1375 and doing it out, you're more than welcome to do that. A lot of people think, oh, we just take this away. We're not taking it away. We're putting a 0 in its spot, which causes it to go away because of the multiplication property of 0. Now to get x by itself, we're going to divide both sides by 5, and so this will make x equal 275. So that means my x-intercept is 275, 0. Now I'm going to do the same process, but this time I'm going to do it for my y-intercept, and the thing that I know about a y-intercept is that my x value is 0. So I'm setting up my ordered pair of something, or 0, something. I want to find this missing y value, but I know that x is 0. So if I do 5 times 0, that quantity would be 0, causing it to disappear, leaving me with the equation 2.5y equals 13.75. Then to get y by itself, I would divide both sides by 2.5, and 1375 divided by 2.5 is going to be 550. So I'm going to graph this up 550 on my y-axis. Now I need to connect this with something straight. Now my next task is, and explain everything makes this a little hard, I'd have to go like this. My next task is to graph my second equation, my x plus y equals 400, using x, y intercepts. Again, for my x-intercept, I know that my y-coordinate is going to be 0. If y were 0, this equation would say x plus 0 equals 400, which means x would equal 400. Which also kind of makes sense, because this means that y, which is students, if the students were 0, but I still needed a total of 400, I would need 400 adults to go. And then the opposite is going to be true for my y-coordinate. That means my x value would be 0, and if x were 0 in this equation, y would equal 400. And again, I need to graph that using something straight. If you're not graphing lines using rulers, you're going to find parts of this very difficult, because it's going to be important that our lines are precise. So it says, use your lines to fill in the table below to find different possible amounts of tickets to satisfy each equation. So one of my tables says ways to make 1375. Well, that was represented in this case by this black line. This line represents all the possible ways I can make $1,375. So any point along this line would make this true. So for example, this looks like maybe it would be a good point here, although it's hard to say for sure, I'd have to check. So this would be maybe 50 and 450. So I'm just going to check that. So I'm going to see, okay, if adults were 50 and students were 450, would this give me the correct amount of money? So I'm going to do 5 times 50 plus 2.5 times 450. So I'm just plugging in these numbers here, and I did get 1375. So this was 50 adults, 450 students. I could even use my intercepts, here, which was 275 adults and 0 students, and 0 students and 550 adults. There's many more possibilities to this. I would just be looking all along this line, and on a graph like this, I'd probably try to find specifically ones on a corner so I'm certain about their coordinates. The other table that's missing here on my video was ways to sell 400 tickets. And so we've seen that already with our intercepts of 0 adults and 400 students, or 400 adults and 0 students. Or I could find anything else along this blue line. These are all the possible ways I could sell 400 tickets. So for example, 300 adults and 100 students would work as well. And so then the next question just asks, is there a way to make both events occur simultaneously? If so, how? We've actually seen this before. That's the solution to our system, which is right there. And so it looks as though 150 adults, 250 students would make this happen. 150 adults, 250 students, which certainly adds to the right number of 400 people, but I would just also check that it makes the correct amount of money by doing 150 times 5 plus $2.50 times 250, which does come out to the right amount of money. And then what are the minimum and maximum of each type of ticket you could sell? So for adult tickets, the minimum was 0, and the maximum was 400, because that was here on my graph. I zoom out a little bit. And for student tickets, again, the minimum was 0 and the maximum was 400. And so we're going to get into tomorrow or Thursday putting these into inequalities to show our domain and range. So on example 4, when I'm finding the x-intercept, I know that an x-intercept occurs when the y value is 0, so I'm simply going to replace y with 0 in my equation, which would get me 5x minus 2 times 0 equals 10, which would get me 5x equals 10, and then if I divide both sides by 5, I'm going to get 2. So I've got 2, 0. And then for my y-intercept, I know the x-coordinate is going to be 0, so I'm going to do 5 times 0 minus 2y equals 10. That would be 0 minus 2y equals 10, which would be negative 2y equals 10. So the big thing on this one is that this negative sign carries all the way through. And so now when it's time to divide by both sides, I'm going to divide by negative 2 to get a y-intercept of negative 5. That's going to get graphed on the y-axis. And when I go to graph this, I need to make sure I'm using something straight in order to have an accurate line. And in this case, I would have arrows on both ends, since my line can extend forever in both directions.